Hey everyone, welcome back to another Vic's Math Corner video. Last time we looked at the coordinate plane, or Cartesian plane, for the first time and plotted some points, but now we're ready to make some graphs. So graphs are interesting and helpful because they can visually show what equations are describing. There are all sorts of types of graphs, which we'll learn about definitely later, but some examples are linear, quadratic, exponential, and there's much more. Today, we're going to be dealing with linear equations, or straight lines, which are, in my opinion, the simplest. So the easiest way to look at what a graph would look like, what the graph of an equation would look like, is to plot out some points of the x and y values. So you can think of y as depending on x. So as x changes, y also changes. In a previous video, we talked about ordered pairs, which tell us the location of points. So our thought process when we create this chart that is on the left side of the screen is that we're going to get a certain number of ordered pairs for points, and then if we connect these points, we're going to get the line for the graph that we want. So let's get started. We are told to graph y equals 2x plus 3. So what should we do here? What we're going to do is write out the corresponding y value for each x value in the chart. So we're going to start with x equals -3 and hit every single x value up until x equals 3. So 7 values in total. Then we'll use these 7 values to plot out on the graph. And lastly, we're going to connect that to form a line, and that will be the graph that we want. So let's start with x equals -3. So what we're going to do is plug in -3 for x in the equation. So instead of y equals 2x plus 3, since we're dealing with x equals -3, we're going to say y equals 2 times -3 plus 3. Here's what we mean. -3 plus 3. So that'll simplify to -6 plus 3 to give us a value of -3. So what this graph is saying, what this equation is saying, is that when x equals -3, the y value will be -3 as well. Next, we're going to have to repeat this process for the rest of the 6 values. So it might get a little redundant after the first few, so I'll speed it up then. So let's erase all of this and move on to x equals -2. So 2 times -2. Oh, let's zoom out a little bit. This is much better. So plus 3, which will simplify to -4 plus 3, or -1. So we're saying when x equals -2, the corresponding y value is going to be -1. Next, x equals -1. So let's plug it in. So y equals 2 times -1 plus 3, and we're going to get y equals -2 plus 3, or +1. So now let's do the same thing for x equals 0. So y equals 2 times 0 plus 3, so 0 plus 3, and we'll get 3. I didn't even have to simplify that one. Next, let's do x equals 1. So 2 times 1 plus 3, so 2 plus 3, 5. Next, let's plug in x equals 2. So y equals 2 times 2 plus 3 to get 4 plus 3, or 7. And lastly, we have x equals 3. So y equals 2 times +3 plus 3. So 6 plus 3, 9. So now just to save some time, I already plotted out these points. So I'll show when these are accurately plotted out. Okay, here we are. So what we did was we went to each value here. So let's look at the first example. -3, -3. So this gives us the ordered pair, -3, comma, -3. So what we did was we zoomed in to x equals -3, where my cursor is. We went down to y equals -3 and made a point. We then repeated the process for all of the other points. So let's look at -2, comma, -1, which we got from this second to top row. Let's look here. So we went to x equals -2, so 2 units to the left from the origin, and then 1 unit down, because -1. And no need to explain the rest of them. So now let's create a line to connect these points. So can we create a line here? Please excuse my artwork. Is this accurate? It's not too accurate, but what we can do is just shift the line using this. And this looks about right. So if you're dealing with, if you have a ruler and a graph on paper, you'll definitely be more accurate, or if you're graphing using an online resource, you'll be more accurate, but that was the gist of it. The equation y equals 2x plus 3 will look like this. Now, you may observe some patterns here. So, what do you notice about each subsequent value? You may notice that they increase by 2 every time, right? So -3 to -1 is an increase of 2, right? Because as x is increasing by +1, as x is increasing by 1, y is increasing by 2. So the same holds true for, let's say, these 2 points, 1, 5 and 2, 7. So it's a +1 increase for x, and it's a +2 increase for y. So why is this? Or more importantly, is this predicted somewhere in the equation? It actually is. And if you look here, if you look closely, you'll see that this coefficient value, or the value before the x, tells us kind of what the technical term is the slope, but kind of how much the y increases per every increase of 1 of x. Don't worry if you're confused, because this will definitely be explained in the next video. Also, this +3, if you're curious, where does this come from? This is actually a value known as the y-intercept. So it tells you at where x equals 0, y equals 3, that I'm circling right now. Y equals 3. And that's the same thing as this 3 that we got here. So thanks everyone for watching. Hope you were able to understand. If you liked it, please like and subscribe, and feel free to write any comments. Thank you.